So I'm going to be talking about ReasonML and GraphQL. Show of hands, who has heard of ReasonML? All right, keep those hands up. Who has used it before? And of those that are still remaining, who has shipped a production project in it? All right, so I hope that we can change some of those, keep some of those hands up longer at the end of this talk. So quick introduction. My name is Sean Grove. I'm coming out of San Francisco. I work at a company called OneGraph. We'll see a little bit of that later. We just finished the Y Combinator Summer 18 batch. Before that, I was running engineering for a payments company. And before that, I did Y Combinator back in summer of 2011. And just as a bit of context, my background, I work a lot, very heavily with Clojure and ClojureScript for the past, 8-9 years. Well, not ClojureScript necessarily, but and then a lot of Reason and Rust these days. So I kind of want to start that, making that transition from a dynamic language into a statically typed language was pretty interesting for me, and in many ways very frustrating. And I think looking back, maybe I would have articulated my aspirations in the promises that typed languages give us. I think the promise of a statically typed language is supposed to be something along the lines of it makes it more difficult to represent incorrect programs. To give an example of this, here's a bit of JavaScript. So imagine that this was a function you were coming across. It's a nice function called insertCustomer. It takes 5 different arguments: name, subname, org, rating, so on. And the challenge here is, in a dynamic language, it's very difficult to know what these refer to, or even know what their types are, necessarily. And this is kind of best case scenario, right? In this case, the developer was very kind. Instead of naming the variables x, y, and t, right, we have name and subname and whatnot. But there's a lot of context that's missing inside of this dynamic function, right? So if I'm looking at insertCustomer, I see that there's an org there. And this feels like maybe this is going to do something with a database. Maybe org is an org ID, or is that like an object of some sort that includes all of the org information? And now if I'm trying to track down a bug, and I have several of these functions in my call stack, I have to navigate through each of them and go actually into the implementation to understand what is it expecting and what is it actually doing. And so there's a lot of ambiguity, and it becomes very difficult. And I think that I will become deeply unhappy fairly quickly by debugging this kind of thing. So I would argue that the type systems, the promise that I actually care about in type systems, is that they promise me that I will be happier by being more productive. And so with that intro, I'll give a quick rundown of ReasonML. So there were a few shows that people had heard of ReasonML. Raise your hand if you've heard of OCaml before, or standard ML. OK, so Reason is actually built on top of OCaml. OCaml is a 25-year-old language that is heavily steeped in academia. It has some really, really amazing features in its type system and what it can do for you. Because of the 25 years of architecture that has gone into this compiler and the tool chain, the compiler is highly modular. It actually has something like 7 different stages. And the first stage is responsible, for example, of parsing a textual representation of your source code into a binary AST. And that's what all the subsequent layers of the compiler work off of. Similarly, you can actually peel off the last layer, which is responsible for emitting, for example, native code or bytecode, and you can replace it with one that maybe emits JavaScript. So by virtue of kind of the modular nature of this compiler, along with all of the academic investment that has gone into it, OCaml has fantastic reach. It's able to go into JavaScript, to desktop, native mobile, not running through some JavaScript bridge, and even unikernels, which are incredibly interesting. There are a lot of problems with OCaml, though. In particular, because it is so steeped in academia, the toolchain is not necessarily up to standard for maybe a professional development. Right? So if I'm writing my thesis in OCaml, in some part of the type system, and it's going to take me 18 to 24 months, maybe it doesn't matter that it takes me 6 weeks to get my development environment set up. But if I'm a developer trying to ship a product, that matters a lot. Right? I'm going to be deeply unhappy within 2 days, maybe, if I can't get anything to run. So Reason comes in and kind of builds on top of that very, very sturdy and very powerful sound base of OCaml and provides a new syntax that looks a lot like JavaScript, and also brings along a set of developer tooling to make that onboarding as easy as possible. And it's still early days for Reason. We just had the first ReasonConf in Vienna back in May, and the second one was just announced for April of next year. And Reason has chosen, I mean, every language typically has a domain in which it excels, or maybe a few domains. Reason has chosen web UIs as its main focus right now. Right? OCaml can do lots and lots of things, but Reason wants to make this part of our lives as easy as possible, to the point where it has incorporated JSX into the syntax. There's no preprocessor step or anything like that. This is part of the Reason syntax to be able to express your web UIs in trees natively. It has things like component state and transitions built in to the de facto UI framework, which is Reason React. And very importantly, it focuses heavily on interop with NPM. Right? So OCaml in particular has a kind of closed world assumption for good reason that we'll see in a little bit. But it assumes that everything is going to be written in OCaml, more or less. You can interop with C and some other things, but it's not particularly easy. BuckleScript and Reason want to make it as easy as possible to pull in all the existing ecosystem of NPM and JavaScript so that we can build and ship as fast as possible. So I assume with that, everyone's really excited. We're already sold on Reason. We want to go right now, actually, probably and hack on Reason. But I would say that there are still some caveats. And this actually applies with all statically typed languages. That within a domain, it may help you quite a bit, but there are still challenges. Right? Sometimes it can be very difficult to know how to represent an idea in a way that the type checker or the compiler is going to understand it. And the canonical example I like to use here is React.js. So despite the extension or the suffix, React.js was actually prototyped in standard ML, which is a cousin of OCaml and Reason. And there was a lot of progress made, and it was very good for scaffolding the initial version of it. However, when it came time to model the state update transition, Jordan Walk couldn't figure out how to represent it in such a way that the standard ML type checker would allow it. So it can be very difficult to represent ideas. And even like worse than that, there are some valid programs, or valid enough, that will never be type checkable. And there's like a lot of research to extend the power of the type systems, things like dependent types and whatnot, that are trying to make it so that the unrepresentable programs become fewer and fewer. But those are many, many, many years out. So typed languages have these challenges. And I think it's important to keep that in mind, because there is a big trade-off whenever you bring in a typed language. So we need to look at what are the positives, what are the promises that they're actually giving us. So Reason, I would say, says that within the domain, if you don't try to do one of these painful things, I'm going to make you very, very productive. So things like building web UIs and whatnot. But as soon as you step out, it's going to be incredibly painful. And I would argue that one of the biggest domains that we face as developers now is interacting with external systems. Right? So for the compiler, it's able to check all of your code to make sure that it is internally consistent. There are whole classes of errors that are impossible to express, which is fantastic. But it can only do that for what it can see. So whenever you do interop with the outside world, whether it's C or JavaScript, you do run into this problem where the compiler is now like a child. It has no knowledge of what the external ecosystem is like. And it will trust you inherently. If you tell it that you're using a JavaScript library, and the JavaScript library takes a string and an integer as an argument, and it returns an object, it will believe you. And if you're wrong, that will be a runtime error. And libraries are well and good, right? It's very important to have a nice ecosystem for a language. But I would argue the bigger challenge here is external APIs. Every app we build at some point, interacts with the outside world via an external API. Very few companies implement everything from the ground up. And in order to interact with the outside world, this basically requires that we speak the lingua franca of today, which is JSON. And this is actually a really big problem for typed languages, right? So in this case, I have a very basic type in Reason. It's beautiful. It's a person with two fields, a name and a city. Both are strings. Neither are nullable. Neither are optional. And then our JSON, it seems to match up quite nicely, right? We have name and city. And to us, that looks very, very similar. But to a compiler, they're totally different things. So let's look at what it actually looks like inside of Reason whenever you're trying to extend the compiler to interact with the outside world. So let's say that we have that JSON from before, and we want to create a record of the person where the compiler can give us all of this nice type checking guarantees. So what I'm going to do, I have a function called parsePersonJSON. It's going to take some JSON and return a person. The first step is I need to parse the name. So I'm going to get inside of the person JSON the name field. But it's JSON, right? It might not actually be there. So this is an optional type. So I'm forced to deal with this and say, all right, well, if it's not there, I'm just going to throw an error, right? That's just bad JSON. I can't recover from that. I can't create a person without a name. But now what I've gotten out is actually a JSON value. And a JSON value can be a string or an integer, an object. So we actually have to say, all right, I want to decode this value into a string. But it's possible that someone put in the wrong kind of value there, and it may not actually be a string, in which case we'll get none back. And again, I can't do anything with malformed JSON, so I'm just going to throw an error. But if it is a string, then I'll get the value wrapped up here, and I'll simply return the value. And I'll repeat that for the city, and now I can create my record. So these two lines and this one line of JavaScript, or JSON, turns into this. But at least we were able to, right? At least we were able to write a parsing function. And we're programmers, so we can program our way out of this. It's not so bad. So let's clean it up a little bit. So in this case, I'm going to build a little function, little helper function, that's going to pluck a field out, and it's going to decode it. And now, like with a little bit of abstraction, I'm able to get it down to 3 lines. So pretty good. But let me show you what it actually looks like in a real-world example. So I shipped this in early 2017. And the biggest problem I had with it, so building a UI in Reason React was a fantastic experience. And the way I did this was I took the response from the server, and I encoded it as a native Reason type, and I built the UI. And it was great. Whole classes of errors were just eliminated by default. However, when it came time to actually hook it up to the real response from the server, this is what it looked like. I had to implement tons and tons of decoding and encoding logic manually for each of these responses. And this is so manual, so tedious, and error-prone. Literally, all of our errors came from this file. And this is for like 4 endpoints on an API. It was horrific. So now we have made a little bit of progress in the Reason world. And so like maybe, again, as programmers, we'll introduce a new layer of abstraction, and we'll metaprogram our way out. So this is called this is an annotation, which the compiler will recognize. And given this annotation, it will walk over the type definition, and it will generate these functions for us. Right? So now we get a person to JSON and a person from JSON by default. So that's pretty nice, right? We've made some progress. We don't have to manually write our converters back and forth. And there's not a ton of boilerplate. But there is still the possibility that the server sends us some malformed JSON. And if you look at the Reason manual, it has this section on how to properly decode JSON. That you are required to recursively parse each field and handle invalid data accordingly. And I have never seen anyone do this actual work. right? It's always just a throw an error immediately. We can't recover from this. So I would argue that on the client, we effectively always have to trust the server. We're at the mercy of the server to send us valid data. It's very hard to recover from it. And so whenever we're making those records, it can be really difficult to know the shape of the data, right? Even though we can metaprogram our way out. So we'll take a look at a real-world example. This is the Github Rest Api. If you hit the Git repository endpoint, this is what you get back. This is one repository. This is a lot of data in one endpoint. It is going to take a long time to enumerate all of these fields inside of our code. In fact, it will take so much time, I would argue, that we shouldn't do it. We should just write a tool. Again, programmers. We're going to program our way out of every problem, right? So maybe what we can do is we write a tool that, this is just JSON. So we'll enumerate over all the keys at each level. And we'll check the type of the value of that key. And then we'll just spit out the record definition. So now we can just take any JSON and spit out some nice reason code. Right? So we can build tools that accelerate these things, which is nice. But look at this. So this is the original. And this is the new one. And this is a real-world example of something that I've been bitten by a lot. The thing that changed is that type is now null. The problem is that the example-based approach doesn't necessarily cover all of the variability, all of the novelty inside of an API. Right? Inside of Reason, a string and a nullable string are different things. And if we don't cover that, and the compiler doesn't expect a string to be nullable, that will be a runtime error. And we've lost all of the safety that Reason was supposed to give us. So maybe we extend our tool. We can fix this, right? So what we do is, instead of collecting one example, maybe we just collect 10, 100, 1,000,000, something like this. And for every time we see a key, we check the value. We see what type it is. And if it's a string, or if it's null, that's maybe a novel event. Every time there's something new that we haven't seen before. If it's always been an integer and now it's a string, or it's always been there and now it's nullable, that's a novel event. And so as the examples flow through, we track the rate of novelty. And as it approaches 0, we're kind of confident, we're getting more confident that we've covered all of the edge cases and the variability inside of an API. And then we can use that data to actually generate lots of different things. So we can generate TypeScript bindings. We can generate reason bindings. We do lots of things with it. So I want to show you a demo of what this would look like. So this is a tool that is going to take some JSON, and it's going to walk over the example, and it's going to generate some type definitions here. And I'll show you another example as well. So you can see that very quickly it walks over everything. And in fact, if we go to the GitHub repo example, rather than writing this all out manually, that is so big. I'm going to come in here and paste it in. And you can see that it generates lots and lots of type definitions for me automatically so that I don't have to write it. And over here is actually some GraphQL resolver code. So I also don't have to write that code, which would be incredibly manual and incredibly tedious as well. So it's really nice to build these tools that actually generate this stuff for us. And this is really the same thing you would do, even in a dynamic language. You would still need to try to cover all of the variability of an API. If you were able to completely cover it and have those guarantees, you would never have, name is not a field of undefined on the front end, because you would have a deep understanding. You would know exactly the variability of the fields on the back end. So we're able to write tools, metaprogram our way out. We're almost there, right? But this is the last vulnerability, I would say, is that I'm going to save you the time. This used to be gist's URL, and someone on the back end got a bout of OCD and decided really it should be called owned gist's URL. So they moved the field. And this happens. I've been bit by this. And no one told you. And, well, probably the person who told you was probably PagerDuty at 3 o'clock in the morning whenever your customers are upset. But if you think about the implications of this, again, we're at the mercy of the server to send us valid data. And so them having moved this means that it potentially invalidates all of our code. Right? Once we've tracked down and we've figured out that this field has moved, I suspect the next feeling you have is you're wondering what else has changed. Right? Like this is a good way to become a paranoiac, where you're just wondering, like, is there going to be another, like, can I go back to sleep right now? Or is there going to be another PagerDuty issue? So I would argue that in any typed language, you have three really big problems. The first is the massive amount of boilerplate it takes to convert from some JSON representation into a representation that the compiler and the type checker understand. The second is the accuracy and the safety of that conversion. Right? It's possible to get fields wrong, and it's possible that you're going to throw an error if you don't totally understand everything. And then finally, the biggest problem is that servers can break everything out from underneath us. So I would say that in Reason, we want four things. We want access to all of the data types in an API. We want to have automatic conversion, automatic access, and guaranteed safety. And we want a guaranteed contract from the server and the client. And we want all of that in an automatic and programmatic way so that we don't have to build those tools one-off. And that's GraphQL. So GraphQL has all of these different nuances built in. So I'll show you a quick example where this is the GitHub repository API. And I'll show you the equivalent in GraphQL. So I'm going to come in here, go into GitHub. I'll pull out a user. I'll pull out the repositories. And then for each of those repositories, I'll pull out the name. So I'll run that, and you can see that this is really, really quick. At any given time, I can hover over the field, and I can see that this is a string, and the bang indicates that this is a non-nullable string. This is huge, right? I can use this type of information inside of my code to make sure that I get all the guarantees that I was looking for previously. And the nice thing is, if I want to add an additional field, I can get just that additional field. I don't have to have, if you remember how big that repository endpoint was? 5 of those would be huge. I'm forced to download all of that data, even if I don't need it. Whereas with GraphQL, I can express not only one endpoint, but I've actually jumped across 2 endpoints here and got exactly the data that I needed. And the way this is done, GraphQL actually supports introspection. So I can ask, for example, let's look in schema. I can say, what are all the types that you have, and what are their names? And I can see here are all the different types that this GraphQL server supports. Right? So I can actually ask, I can introspect a server and say, hey, what is the contract that you're offering me that you guarantee that you're going to have? And this is going to return something like this, where we get the schema and the query type and whatnot. And so in Reason, we have variants, a bit like enums. And so a project state really can be 2 things. A project state can either be open or closed. And it's pretty succinct in Reason, but this is how you would represent the equivalent in GraphQL. And the nice thing is, that's JSON, right? We all know how to work with JSON. And so now we have this kind of nice isomorphism where we can work between, we can take the server's representation and generate our Reason representation automatically. Similarly, if I have a user with an avatar URL, this is maybe how I would represent it. So I would say that the marriage of these 2 things extends the Reason's domain by such a large factor. In fact, any typed language's domain by a huge factor. So I want to show you what this actually looks like when you put it all together. So here's what it looks like whenever I'm working with our API. So this is Reason, and I'm able to co-locate my GraphQL query here alongside my component that's going to be rendered. And right now I have a query that's just going to check if I'm logged in. And right now it's parameterized by an email variable, which is a nullable string. But I'm going to come in here and I'm going to make it so that this string is non-nullable. And as soon as I do that, I have an invalid program. Because in my query, where I actually use it, it's saying, hey, this email variable is non-nullable. You have to require it. So now I'm going to add it, and now it's good again. So I have this really nice way of iterating through my program and making sure that there's type safety all the way through to the server. And now whenever I actually deal with the response from the server, the response can be in 3 states. It could be loading, it could be failed, or it could have some data. And if it has some data, I'm going to go ahead and pluck it out. And if you can see down here, for me, this is amazing. It knows the exact shape of the response from the server. It knows the types. And so we can do some pretty amazing things where we get, for example, autocomplete along the way. So in this case, for example, let's say that I thought, maybe this was called name rather than full name. And as soon as I hit save, it's going to say, hey, this field name does not exist. Did you mean full name? And as soon as I try to type full name, it's going to autocomplete. Right? There's something magical about being on the client and being able to autocomplete through a server's API. Right? That's such a difference in developer experience, being able to explore the API from within your own editor. So, on the front end, with ReasonML and GraphQL, what do we get? On the GraphQL side, we get extremely powerful clients that give us exactly the data we need across lots and lots of different resources. So we no longer have overfetching or underfetching. We also have reduced latency because everything is together in one call. On the Reason side, however, Reason gives us a safe client that will not compile if the server cannot satisfy our query. We're also forced to make sure that we deal with all of the nullability checks. There's no more runtime exceptions for undefined, or name is not a field of undefined. And I think this is really unique because typically power, ease, security, they're all at odds. This is a really rare case where this is actually easier than the alternative. It's faster, and it's safer. So I won't go over how to actually use it on the front end. It's very, very quick. Within 5 minutes, you can do a create React app, add Apollo GraphQL, and you'll be good to go. The back end, however, is also, I think, very important for us as developers. So I spend most of my time on the back end. And I think that as a back-end developer, while it can sometimes be bothersome to deal with front-end clients, it's important. I generally see them as doing a more important job than me. They actually control the user experience. And so my job is to serve them and to make them as productive as possible. So I try to keep in mind they want to be productive. They want to have safety, they want to have stability, and they want to have certain guarantees. For example, if as a backend provider, I say that I'm going to return a certain type, I will always return it. And if I say that it's non-nullable, I'm never going to return a null. And really, I want to be as courteous as possible. So I want to do this on my time, not theirs. So GraphQL.js, for example, the reference GraphQL implementation, will do these type checks, but it will do it at query time. So it will run a query from a client, and it will execute everything, and then it will check the result to make sure that none of these guarantees have been violated. And if it has, it will go ahead and throw an error, and then the client will have to deal with an error. They'll never see malformed data, but they will see more errors. Whereas what I want is for something like Reason to go ahead and give me the guarantees that I will never expose my clients to those errors as much as possible. And the difficulty here is maintaining these guarantees as your schema grows. So Facebook's schema, GraphQL schema, it's probably the oldest. It's from 2012, I believe. And it's, I think, more than 40 megabytes. Ours is upwards of 20 megabytes. That is a huge schema. And especially as your team grows, right, it's very difficult to maintain these guarantees across your team. And one that resonates with me probably is pushing at 7:30. You're just going to push a real quick commit on Friday, and then 2 o'clock on Saturday, you promise you'll never do it again. So I would say that the best way to write a GraphQL server is with a project called ocaml-graphql-server. It is by far the best GraphQL server in the world, with the caveat of I have not used any others. So take it with a little grain of salt. And just to show you what this would look like to actually build a real GraphQL server. if we have a type of user here, I'm going to translate from the type and say that I have this GraphQL object called the user, and I'll give it a documentation for the user to be able to see. And it has these two fields, an ID and a name. And so I just kind of build these resolvers, these objects with certain fields. And then finally, I put it together in one big schema object. And now I'm going to have static guarantees that my program is going to deliver the right response to all my clients. And they'll be able to introspect and get all those guarantees that we saw before. And this is, I think, really, really powerful. So for us, on every time we build push to CI, we actually build the new server. And what it does is it downloads the current production schema, and it downloads the one we're about to push. And because it's just JSON, it's really easy to do a diff and to figure out, are we pushing any breaking changes? Are we about to break any of our clients? And if we are, then we fail the build. We do not break clients. And this is so difficult to do without something like GraphQL, without introspectable schemas on the server. Now, there are some limitations on both the front end and back end. Not all of the GraphQL spec is covered in Reason. And there are probably some caveats, like it'll always be behind the reference implementations. On the back end, I'm happy to say that I think 3 or 4 months ago, a lot of these were unknowns. And there's been a lot of progress. So now, actually, a lot of the GraphQL schema is covered pretty well by ocaml-graphql-server. We're pretty happy with it so far. And I want to give a quick demo of what it would look like if we have this ability to do in-editor, autocomplete, type checks, all this nice stuff, where it makes it actually easier for a statically typed language to access these external APIs than a dynamic language for the first time. I actually think this is very reminiscent of ClojureScript before React. So David Nolan talked about this, where ClojureScript was a really fun hobby project, but it wasn't really real. Because you could do all of your beautiful functional programming inside of ClojureScript, but as soon as you touched the DOM, the mutable DOM caused all that beautiful functional programming to be thrown out the window. And so you couldn't really build real things with ClojureScript until React came along and recovered that and extended the domain for ClojureScript so that now it's used at tons of companies. Similarly, for statically typed languages, I think that they were very restricted before, because communicating with the outside world is a fundamental necessity for our servers, for our clients. And so being able to extend that domain so that it's actually easier than the alternative has huge implications. So let's imagine, for example, if the entire world, if every API was built with GraphQL. It might look something like this. So let's say that I'm dealing with the YouTube API. I'm going to build a little app that, given a video ID, is going to pull out some information on that video. So I'm going to come in here and type this out. And I'll get the title of this. I can run that. And maybe I'll get the channel ID. And this is typically where REST would end, right? Having gotten a video out, you would pluck the channel ID off, and you'd make a subsequent request over to the channel endpoint. But really, maybe I just want to know what channel was it uploaded to. So I'm just going to hop over to there. And I'm going to pull out the title. And I was able to traverse over these two different APIs. But the cool thing is that on YouTube, you can associate your channel with external media, things like Instagram or Twitter. So I'm going to say for every Twitter account that this channel is associated with, I want to pull out the first 25 tweets. And now we're in the Twitter part of the API. And now for each of these tweets, I'm going to pull out the text. And the Twitter API has this concept of entities. So I'm saying in those first 25 tweets, for any user who was mentioned, I'll get their screen name. And also, let's get their first 25 tweets. And now the obvious thing to do, having gone from YouTube video to a channel, over to Twitter, to all the way at the edges, is that if anyone tweeted about a video, we want to hop back over into YouTube and pull out the title of that. And while we're there, let's pull out the statistics and get the view count and the like count. So we'll run that. We'll make 30 or 40 API calls. We'll mesh it all back together. And so you could imagine that autocomplete inside of your editor, that type safety across all these different services, is so phenomenally better than the alternative. It's crazy. So this is what I work on. This is one graph. And I would argue that, in conclusion, if you like anything about statically typed languages, please build your APIs with GraphQL, because it will extend everyone's ability to use them in real-world scenarios. And I'll show you one last demo, just for fun. So you can build such nice tooling because of this introspection. You don't only have read-only access. We have write access as well. So this is actually how most people use GraphQL in our service. They just kind of come over here and they're able to explore and just see what's available. So in Zeit, I see that there's a purchase domain thing here. I'll say maybe I'm willing to spend $13 on it. And I'll do Øredev, GraphQL demo, 2018.com. And I'll run that. And this is going to take a little while because it's actually dealing with upstream domain providers and whatnot. But exploring an API like this, you can imagine if this was in your editor, being able to kind of click through and see everything that an API has to offer, and to know that the server is going to give you those guarantees, it's huge. All right. This will be the last thing, whether it succeeds or not. Fingers crossed. Oh, man. All right, cool. I now own Øredev GraphQL demo 2018.com. OK, that is it. Thank you very much.